Welcome back again. We're still in Module 10, but now we're going to transition from remote sensing over to GPS. So last time I talked about active remote sensing, and remember there were three different flavors of that I talked about. There's LiDAR, lasers, there's radar, radio waves, and there's sonar, sonic waves. All of those have an R at the end, and that R stands for ranging. And although I didn't really go into that very deeply, ranging allows you to tell how far away the object is because it's counting the amount of time it takes for the signal to get to the object and come back in active sensing, in remote sensing's case. GPS is going to be really similar, so when you pay attention to this, you'll learn a little bit more about how active remote sensing works. Okay, the world of GPS is the world of acronyms, and I'm not going to go through all of these acronyms, but I will let you know that if you want to learn more about GPS, you're probably going to have to get used to dealing with these acronyms because they're used in almost all of the material that describes how GPS works. But GPS itself is an acronym, and that stands for Global Positioning System. And it turns out that the Navstar system is the system that we use in the United States, and that stands for Navigation System Using Timing and Ranging. And you see ranging again there. That's going to let us know how far away something is. Okay. So Navstar GPS, that's the United States GPS. There are three segments. The space segment, that's the satellites that are out there, the GPS satellites. The control segment, and that's the whole system on the surface of the Earth that keeps the satellites in orbit, keeps them working properly, keeps everything coordinated, and then actually sends data along the surface of the ground that can be transmitted up to the satellites or accepts downloaded data from the satellites. The user segment is the GPS receiver, and that's what you use to find out your location. And what a lot of people will say is the GPS talks to the satellite, and that's one of the things you have to understand is the GPS does not talk to the satellite, it listens to the satellite. So a GPS receiver, which is the user segment, is only a listening device. It's not a talking device. So there are a bunch of satellites out there, 32 plus or minus, depending upon whether there are spares or some of the satellites aren't working. They're all orbiting in different orbits. I'll talk about this in another video. And what this animation shows is the blue point is a point on the surface of the Earth. And when it has green lines connecting to a satellite, it means it can see those satellites. The red ones are the satellites it can't see because it's out of the range of vision of that satellite. So you can see that any given point in time, if you're not indoors or under a tree or something like that, there are on the order of 9 or 10 or maybe even more satellites visible. Okay, so how the heck does this GPS thing work? This is the simplified version. Each satellite knows where it is. So it's out there orbiting the planet at some point. It knows where it is. The control segment is going to help it remember where it is and to correct where it thinks it is when it gets a little bit off course. So the satellite knows where it is. Satellite knows what time it is. Really precisely knows what time it is. Each satellite has 4 different atomic clocks in it. And again, the control segment is going to keep that satellite clock set synced to what the precise atomic time is on the surface of the Earth. So satellite knows where it is, and it knows what time it is. And it sends out these signals, and the signals travel at the speed of light. So it knows where it is, what time it is, and we know that the signals travel at the speed of light. So how does that work? Well, there's a basic equation. If you have something that's traveling at the speed of light, which is c, 186,000 miles per second, and you know how long it takes the signal to get to you, so you know when you get the signal, it's right now. The signal itself will have data in it that says, I sent this signal at a certain time. So you subtract when the signal was sent from when you get it. That gives you an amount of time. You know that amount of time times the speed of light. That's going to tell you how far you are away from that satellite. So that's the basic equation that's going to be applied. Okay? So after a certain amount of time, there's a radius that the signal has reached, and if you're at that radius, you're going to get that signal. Speed of light, 186,000 miles per second. So think about this for a minute. If you had 1/10,000th of a second to count, 1/10,000 of a second, that signal will go 18.6 miles. So we go over here 4 digits, 18.6 miles. So if our clock is good to 1/10,000th of a second, which is pretty good, our location is going to have an issue of at least 18-mile error. So we have to have really good clocks to make this stuff work. KT now is when we get the signal. T sent is when the satellite sends it. It includes timestamp information in the signal that says I'm sending this signal right now. Okay, so if we have one satellite out there and we get it after a certain amount of time, we know that the radius of that signal in a spherical way is, let's say, 12,000 miles. Okay? So if we get something in a certain amount of time that says it's 12,000 miles, we know that we're somewhere 12,000 miles away from the satellite on the surface of this sphere. But if we have two satellites, and we get the signals from the two satellites at different times, we know that we're on the sphere from the first satellite, and we know that we're on the sphere from the second satellite. The intersection of those two spheres is a circle. So now if we have two satellites, we know we're somewhere on this circle. Can't tell for sure where, but we're somewhere on the circle. Let's add another satellite. If we have three satellites now, the first satellite defined this sphere, the second satellite defined this sphere, but its intersection gave us a circle. The third satellite is going to define this sphere, and the intersection with the other two satellites are going to give us 2 points. And generally, one of these points is going to be far enough away from the surface of the planet that we'll be able to just say, well, we know it's not that point, so the only other point it can be is this point. That's where we are. So that's what it does, is it triangulates using signals from the satellites. Okay, so how does it work mathematically? We got three equations when we have three satellites. Each equation describes that sphere that the satellite signal is at. We got three unknowns. We don't know what the x or the y or the z coordinate of our location is. So we got three equations, we got three unknowns. You remember from Algebra 2 that you can solve three equations with three unknowns by doing a whole bunch of different things. You know that from Algebra 2. I'm not going to go through that. So we're good to go, right? Well, not quite. What's this but about? Three equations, three unknowns, we should be good to go. Okay, the GPS satellites have these atomic clocks. There's 4 of them on each satellite. They're really precise. They keep them really good time. But the GPS receivers don't. If the GPS receivers had to have 4 atomic clocks on them, nobody would be able to afford having a GPS receiver. So the GPS receivers don't really have outstanding clocks. And remember, 1/10,000th of a second is 18 miles. So we got to have a really good signal so that we know what time it is when we get that satellite signal. So the satellite clock and the receiver clock might not be exactly in sync. They might not be at exactly the same base time. And we use that time now from our receiver to calculate all these things. So we're going to have an extra unknown. That's going to be the time now. So now we've got 4 unknowns. We've got 3 equations. We're not going to be able to solve that, are we? How are we going to solve that? We need a 4th equation. We just have to have a 4th satellite. So in order to get good location information on your GPS receiver, you have to be able to receive the signal from 4 separate satellites. So in a nutshell, that's how GPS works. Next time, I'll talk a little bit about the infrastructure, about these user segment, control segment, satellite segment, what it's all about in terms of the hardware and the logistics of how it all works. So that'll be next time.